Hi students, in this video we are going to study about the electrolytic dissociation and the theory associated with this electrolytic dissociation, mainly the Arrhenius theory. Arrhenius theory put forward at about 1987, in the year 1987. So what are the different postulates or what are the main points of this Arrhenius theory of electrolytic dissociation is going to study. First of all, he told about the dissociation of this electrolyte in water. So he told that electrolyte dissociate or dissolved in water or dissociate in water into electrically charged particles that are called as ions. And this dissociated ions total charge, that means the charge of positive and charge of the negative ions will be same. So the solution will become as a neutral. So, and also the next point is at finite concentration, electrolyte will be only partially ionized to a degree depending upon the nature of the substance, and that means the concentration and also the temperature. And after this partial dissociation, these ions are having a dynamic equilibrium with unionized molecule and also unionized electrolyte. There will be a dynamic equilibrium between the unionized molecules and ionized molecules. The extent of ionization varies with concentration. While increasing the dilution, the extent of the dissociation or ionization will increase and reaching the maximum at high dilution. And ions are free to move independently under the influence of an electric field. And positive ions will move to the negative electrode or negative ions will move to the positive electrode. Ions, the conductance of the electrolyte of this electrolyte solution is due to the migration of ions towards the oppositely charged electrode. Greater the ionization, greater the conductance. With respect to the colligative property, ions act as the same manner as unionized molecule. The property of electrolytes in solutions are the properties of the ions they furnish. That means the property of electrolyte depending upon the properties of the ions that occupy. And the properties of acids and bases are respectively due to the H plus and OH minus. These are the example for this statement, and they furnish in a solution. So these are the 9 points that Arrhenius discussed about the electrolytic dissociation. We know that there are two types of electrolyte. One is a strong electrolyte, another one is a weak electrolyte. Strong electrolyte means it has moderately high concentration, also it will ionize completely. That is strong electrolyte. Which are not completely ionized at moderately high concentration is known as a weak electrolyte. And the following factors can explain by this Arrhenius explanation of this electrolytic dissociation. First one is the electrolysis. The electrolysis, when a difference in potential is applied across the metal electrode, dipping in the solution of an electrolyte, ions will move towards the oppositely charged ions. These ions is formed by the dissociation of this electrolyte. So we can say that it is obey the electrolytic dissociation theory of this Arrhenius. And non-electrolyte do not produce ions, so they are not unable to conduct electricity. Electrolysis, mainly the electrolysis properties is depending upon the dissociation of the electrolyte. And increase in the molar conductivity, the dilution also explained by this electrolytic dissociation theory. And ionic reactions. Example is silver nitrate and also sodium chloride is together, if we are preparing the solution, what will happen? AgCl will precipitate out. That AgCl precipitating out is due to the dissociation of this silver nitrate as silver plus ions and nitrate ions, and NaCl as Na plus and Cl minus ions. And also it can explain the abnormality of high colligative property of electrolyte in aqueous solution as compared to those of non-electrolyte. Colligative property എന്താണെന്നുള്ളത് നിങ്ങൾ പഠിച്ചിട്ടുണ്ട്. അപ്പോൾ അബ്നോർമാലിറ്റി ഓഫ് colligative property of electrolyte കാരണം അതിലുള്ള നമ്പർ ഓഫ് അയോൺസ് ആണ് അവിടെ പാർട്ടിസിപ്പേറ്റ് ചെയ്യുന്നത്. അതായത് നമ്മളിപ്പോൾ NaCl ആണ് നമ്മൾ ഇലക്ട്രോലൈറ്റ്, നമ്മൾ NaCl എന്ന് പറഞ്ഞ ഒരു മോളിക്യൂളായിട്ടല്ല, ചിലപ്പോൾ അത് Na പ്ലസ് അയോൺസ് Cl മൈനസ് അയോൺസ്, അപ്പോൾ നമ്പർ ഓഫ് അയോൺസ് വിൽ ഡിഫറെൻറ്റ്. സോ അബ്നോർമാലിറ്റി ഓഫ് ഹൈ colligative property of the electrolyte in aqueous solution will observe. This also can be explained by this Arrhenius theory of dissociation. But there will be some limitations for this Arrhenius theory. First one, Arrhenius simply assumes that the presence of ions in aqueous solution of the electrolyte. It does not explain why ionization occurs only in water. And Arrhenius theory cannot explain the for the strong electrolyte. There are anomalies arises for the strong electrolyte. Example, Oswald dilution law cannot explained for the strong electrolyte. And next one, and also it told about only in the water, so it cannot explain the ionization of a fused state or in the absence of water, and because the fused state also conduct the electricity, so it cannot explain the ionization property of fused state. And Arrhenius assumes that there is an independent existence of ion. So it fails to account for the factor which influence the mobility of the ions. That means the electrostatic forces between the ions. So he cannot, he fails to explain that electrostatic attraction between the ions, because he considers it as an independent existence of ions also. And degree of dissociation values of strong acid and strong bases were found to be decreases concentration. And it cannot explain why heat of neutralization strong acid with a strong base is found to be independent of concentration. And could not explain the variation of transport number of ions with the concentration. What is meant by what is mean by transport number? The factor transport number we will study in this chapter later. So these are the limitations of Arrhenius theory. Next, what is Oswald dilution theory? According to Arrhenius theory, there will be a dynamic equilibrium between the ions and unionized electrolyte solution. Oswald explained this in a mathematical way by applying the law of chemical equilibrium in such a system. So, considering an electrolyte, it can be represented as Ba, and the initial concentration of that electrolyte is C before going to dissociate. After dissociating, it will form B plus and A minus ions, and we assuming that alpha is the degree of dissociation of this electrolyte, then we can say that at equilibrium concentration, this B plus ions and A minus will be initial concentration C into degree of dissociation alpha, and C into degree of dissociation of alpha. But in the case of Ba, what will happen? It will be 1 minus alpha. Degree of dissociation is alpha, then the concentration B will become 1 minus alpha into C. Then we are going to apply the law of chemical equilibrium. So, equilibrium constant, we can say that the product of it is the ratio of the product of the product, concentration of product to the product of the concentration of reactants. So, this is the reaction. So, concentration of product is C alpha into C alpha, that will be divided by concentration of reactant, that is C into 1 minus alpha. You can say We can write it like that. Then C can be cancelled. So K will be equal to C alpha square by 1 minus alpha. This is the mathematical expression, or it is the mathematical expression for the variation of degree of dissociation of an electrolyte with the concentration. Degree of dissociation of an electrolyte with concentration, mathematical representation. This is known as Oswald dilution law of binary electrolyte of type Ba. Then, suppose V is represent the volume of solution that containing 1 mole of the electrolyte. So, concentration C will be equal to 1 by V. So, this concentration term we can change into 1 by V. And considering for a weak electrolyte, alpha is very less than 1. So, then 1 minus alpha will be negligible, or 1 minus alpha, here alpha will become negligible and it will become 1. So, K is equal to, here this becomes C alpha square, or in the term of volume, K will be equal to alpha square by V. So, alpha can be written as root of K by C, or alpha is equal to root of K into V. So, from this equation we can say that for a weak electrolyte, the degree of dissociation is inversely proportional to square root of the concentration, and also it is directly proportional to square root of the volume containing 1 mole of the weak electrolyte. And what is the limitation of this Oswald dilution law? It is only applicable to weak electrolyte, because it is based upon the Arrhenius theory. Since that only a fraction of electrolyte is dissociated at ordinary dilution, and that complete dissociation occurs only at infinite dilution. This is true for only weak electrolyte. Strong electrolyte is completely ionized even at the moderate concentration. So, we cannot say that there is an equilibrium between the unionized or anionized ions. So, this law can be applied to only weak electrolyte. And next we are going to deal with the different application of this Oswald dilution law. First one, the calculation of degree of dissociation of degree of ionization of weak acids and bases. So, considering this is the acid, weak acid HA, and this ionization in water, we can say it as H3O plus A minus. On applying the Oswald dilution law, we can say that C alpha square by 1 minus alpha. So, equation here Ka will become ionization constant, because it is the weak acid's ionization. Otherwise, we can say it is a equilibrium constant, but here it is, we are expressed in ionization terms, so we can change the K as Ka. So, Ka is equal to C alpha square. So, alpha is equal to root of Ka by C. And in the case of weak base, BOH is ionizing like that, B plus OH minus. So, alpha of dissociation of this weak base can be written as root of Kb by C. So, degree of dissociation of weak acids and weak bases can be calculated by knowing the ionization constant of acid and ionization constant of base. Next, the calculation of pH on aqueous solution of weak acids and weak base. For an equilibrium weak acid HA, so we know that H3O plus will be equal to C alpha. So, pH will be equal to minus log, pH എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താണെന്ന് നമുക്കറിയാം, മൈനസ് ലോഗ് H3O പോസിറ്റീവ് ആണ് അതിൻ്റെ കോൺസെൻട്രേഷൻ. അപ്പം H3O C ആൽഫ ആണെങ്കിൽ നമുക്ക് എന്ത് കിട്ടും? pH is equal to minus log C alpha. അപ്പം അതേപോലെ തന്നെ OH മൈനസിന് എന്ത് എഴുതാം? POH മൈനസ് log C ആൽഫ. pH എന്ന് പറയുന്നത് നമുക്ക് എന്തറിയാം? pH എന്ന് പറയുന്നത് എന്താണ്? 14 മൈനസ് POH ആണ്. അപ്പോൾ from that, so from these two equation we can calculate the pH of the weak acid and pH of the weak bases. And next application is the calculation ionization constant of weak acids and weak bases. We know that degree of dissociation alpha is lambda mc by lambda molecular entity. So, alpha, if we know the alpha and concentration of C, we can calculate the ionization constant of Ka and the ionization constant of Kb. So, These are